Hi class, this is Dr. Karsten, and today we are going to go over adding and comparing fractions, practice quiz number 2, and this is from Module 5, Grade 4, Engage New York Math, and let's get started right away. So I hope that everyone put the correct code in our secret code box from yesterday, and I will be telling you what the code is for today in this video. But let's jump right in. We've been doing this for a while, so I don't think that I need to go over a big review, and we can just get started. So for question number 1, it says add each pair of fractions. Remember to convert any fractions greater than 1 to mixed numbers. So remember that we are going to be looking for a couple different kinds of fraction pairs. We're going to be looking for ones where they have common or like denominators. We're going to be looking for ones that have related denominators, and we're going to be looking for ones that are just completely different denominators, where they're unrelated. So let's get started. So here in this first problem, I can see that we're adding 4/7 plus 2/7. Now, if something looks like this and you're not really comfortable with the way that it looks, don't hesitate to go ahead and rewrite it in a way that might be more comfortable for you. So for example, I think that most of you like this format better. And so here we can see that we have 4/7 plus 2/7. And remember, when our denominators are the same, we can just add the numerators together. So I can just add 4 plus 2, which is 6, and then I just keep my denominator. And remember, the denominator is telling us the size of the pieces, or how many pieces make up a whole. So it's really like a label when we're adding or subtracting. And then the numerator is telling us how many pieces we have, or how many parts or units we have. So here, it's almost like talking about apples, and I know I keep going back to that, but we could say 4 apples plus 2 apples is 6 apples, so 4/7 plus 2/7 is 6/7, and that's it. So again, this was one of those where the denominators were the same. So I'm just going to put denominator same, and that's also known as common or like. I'm just going to write that the first time so we have all this vocabulary for us. And I'll go ahead and write it. Denominators are the same. Okay, so let's take a look at the next question. So 1b is asking us to add 2/3 and 5/6. And again, I'm going to rewrite it in a way that you might like better. So I'm going to rewrite it as 2/3 plus 5/6. And when I look at this, clearly these denominators are different. 3 and 6 are not the same denominator. So the next question that I ask myself is, are they related or unrelated? So remember, question number 1, same or different? Here they were the same, here they're different. Now if they're different, you go to question 2, which is, are they unrelated or are they related? And in this case, they're related. And what that means is that one of them is the multiple of the other one. 6 is a multiple of 3, so these are definitely related. So when they are related, what you can do is you can take the smaller number, so not necessarily the smaller fraction, but the smaller number in the denominator. In this case, 3 is a number that is smaller than 6. And you can turn that 3, you can decompose it, those thirds, into sixths. So what I'm going to do is I'm going to take this 2/3 and I am going to decompose it into sixths. And the way I'm going to do that is by multiplying. So you have to ask yourself, 3 times what number is 6? Or another way to think of it is 6 divided by 3 is going to give you that number. And 6 divided by 3 is 2. So I know 2 goes there. And whatever I do in my denominator, I must do in my numerator. So I'm going to put a 2 up top also. And now I can go 2 times 2, which is 4. So now what I know is that 2/3 and 4/6 are equivalent fractions. So instead of adding 2/3 and 5/6, I can put 4/6 over here and do 4/6 plus 5/6. So let me go ahead and write that. And it's getting a little, I don't want to crowd it in over here, so I'm going to write it underneath this. So I'm going to take 4/6 instead of 2/3 and add that to the 5/6. And when I do that, 4/6 plus 5/6, there are 4 of those sized pieces, plus 5 of those sized pieces gives me 9 of those sized pieces. And what size are they? They're 6. But now what you notice is that we have a fraction greater than 1. And remember that one of our instructions was to remember to convert any fractions greater than 1 into mixed numbers. So for this one, because I have a 6 in the denominator, what I remind myself is that 6/6 is equal to 1. So 6/6 is equal to 1. So I want to see how many groups of 6/6 I can pull out of there, how many groups I can find. So I have 9 pieces. I'm going to put 6 pieces right here, and that leaves me 3 pieces here, and that's because 6 plus 3 is 9. Well, this 6/6 is the same thing as saying 1, and then I keep my 3/6. So this is going to be my answer. I'm going to get 1 and 3/6. So 2/3 plus 5/6, I converted 4/6 into, 2/3 into 4/6. I added them, and then I went ahead and converted this number, fraction greater than 1, into a mixed number. All right, so let's go ahead and do the next problem. So in the next problem, I have 2/3 plus 4/5. And I'm going to actually stop right now, and I'm going to give you the beginning, the first part of our secret code for tomorrow. And the first part of our secret code for tomorrow is pizza. All right, so pizza, P-I-Z-Z-A, pizza. Okay, so let's take a look at this one. And we can see that we have 2/3 plus 4/5. If you want to, you can rewrite it. So I'm going to go ahead and do that. I'm going to write it right here. So we have 2/3 plus 4/5. And the first thing I want to do is I want to see, are my denominators the same or different? And they are different. 3 and 5 are not the same, so they're different. And the next thing I want to do is I want to ask myself, are they related or unrelated? So in this one, is 5 a multiple of 3? And it is not. So these are unrelated. So my rule, when I have two fractions that are unrelated, is that I'm going to multiply the fraction by the other fraction's denominator. And I'm going to do that for each fraction, for both of them. So let's go ahead and let's first do it for 2/3. So I'm going to take 2/3 and I am going to decompose it. And the way I'm going to decompose 2/3 is by multiplying it by the other fraction's denominator, which is 5. I can see here's my fraction, here's my denominator. So I'm going to put a 5, and whatever I put in the denominator, I have to put in the numerator. So here we have 2 times 5 is 10, and 3 times 5 is 15. So now what I know is that 2/3 and 10/5 are equivalent. They have the same value. Here it's just cut up into more pieces. So I can now take that 10/15 and I can go ahead and write it right here. And now I'm going to switch colors for working with the next one. So now we're going to take 4/5. Let me see what happens if I go over it. So now we're going to take 4/5, and I want to decompose that as well. And again, the way that I'm going to decompose the 4/5 is by multiplying it times the other fraction's denominator, which in this case is a 3. So I'm going to go ahead and write 3 for both the denominator and the numerator, and now I can just multiply across. 4 times 3 is 12, and 5 times 3 is 15. So now what I know is that 4/5 and 12/15 are equivalent fractions, which means that I can substitute in 12/15 for the 4/5. So I'm going to put 12/15 here. Let me go ahead and write in our addition and our equals symbols. Okay, so now that I have common denominators, now that my denominators are the same, I can just add straight across. So I'm going to do 10 plus 12 is 22. And I keep my 15ths because that's telling me the size. So again, 10 of those pieces plus 12 of those pieces gives me 22 of those pieces. What size are those pieces? They're 15ths. So I'm going to pause for a second. And I just want to point something out, that we're using this technique specifically with unrelated denominators. You could have used this with related. It's just going to give you a larger denominator, which for right now is fine, but our goal is always to try and get the smallest denominator because it's going to be easier to work with. Why is it going to be easier to work with? Well, you're going to have to do things like taking a fraction greater than 1 and converting it into a mixed number, and it's easier definitely when you have smaller numbers. So like I just mentioned, we have a fraction here greater than 1. So what I want to do is I want to convert this into a mixed number. And what I know is, look at my denominator's 15. I know that 15 fifteenths is equal to 1. So I'm going to pull 1 out, and I want to do as many groups of 15 fifteenths as I can. So for here, if I have 22 pieces and I pull out 15, that is only going to leave me another 7 fifteenths, another 7 pieces. Now what I know is that this 15 fifteenths is equal to 1. I'm just going to write it over here. And then I keep my 7 fifteenths. I'm going to go ahead and give us a little arrow over to there. And so this is going to be my answer for this one. So it's 1 and 7 fifteenths. All right, so let's jump into comparing fractions now that we finished adding fractions. So for comparing fractions, remember we're going to have a whole bunch of different ways or types of fraction pairs that we're going to look at. We're going to have where the numerators are the same. We're going to have where the denominators are the same. We are going to have where nothing is the same. And then we are also going to have where the where we're going to have fractions greater than 1, and we want to convert those into a mixed number before we compare those. So let's see what this fraction pair is about. So it says compare the following fractions. Oh, let me move this up. And then it says write greater than, less than, or equal to between the fractions. Oh, sorry guys. All right, so if I look at these, again, I think some of you are more comfortable if we rewrite them into this form. And here what you can see right away is that our denominators are the same, which means that the size of the pieces or the parts is the same. So I can just look at the numerator and see who gets more of those pieces, right? So everyone's getting sevenths. Everything is sevenths. Who gets more? 3 sevenths or 5 sevenths? You want to go with the 5 sevenths. Definitely getting 5 pieces of cake is going to last you a lot longer than 3. So I'm going to go ahead and show the alligator eats the bigger number. All right, so that was the first one. And a bunch of these are going to be really quick like that. So there's going to be a bunch. We're doing a whole bunch of these. But many of them are going to be super duper quick. So let me just flip pages for us and get us all set up. Go back to the top. There we go. And I know you just kind of got a preview that we have a bunch. But again, they're quick. Okay, so let's take a look at the next one. And for this next one, we can see that we have 2/8 and 2/5. So I'm going to rewrite this again because I think, let me slide it down a little for us. I think it's easier then for some of you. So we have 2/8 and we have 2/5. And for this one, what I'm noticing is that my numerators are the same. So I have 2 pieces in both situations. Here I have 2/8, so I have 2 pieces that are 8ths, and here I have 2 pieces that are 5ths. So since I have 2 pieces in both of these, I can just look at my denominator and decide who gets bigger pieces. And remember, when I'm cutting something up into 8 pieces, those pieces are smaller than when I'm only cutting it into 5. Think again in terms of sharing something like, I don't know, cake. Would you rather share cake among 5 people or among 8 people? If you only have 5 people, those slices are much, much bigger. And let me do a super duper quick tape diagram just to kind of show you how the slices are different. So if I'm doing 5ths, so we have 1, oh, that's not a great one, but 1, 2, 3, 4, 5, versus if I'm doing 8ths. So here you can see that each one of these slices is much smaller than these pieces. And again, pretend that's over more. So if I color it in, and I'm going to color in 2/5 right here, and then I'm going to redraw my line. And so I'm going to move it over a little for us. So we're going to put it right there. So I just moved it over a little to make it work better. So now there you can see I have 2/5, and let me do 2/8. And you can see that 2/5 is a lot bigger than 2/8. So let's go ahead and write that. So again, when the numerators are the same, look at the denominator and see who's getting larger slices. a smaller number, 5 is a smaller number than 8, means you're getting bigger pieces because you're dividing it into fewer pieces. So fewer pieces are happening there. Okay, so let's take a look at the next one. So here we have 2/3 and 4/7. And again, I'm going to go ahead and rewrite this. So we have 2/3 and we have 4/7. And for this, my numerators are different and my denominators are different. So you have a couple of different choices. One is that you could put these on a number line and you could use benchmarks. So I'm going to go ahead and do that. So I'm going to have 0, 1/2, and 1. And then if I wanted to put my thirds on here, I know that I would have something like 1/3, 2/3, 3/3. So I know that my thirds are going to fall on either side of this half. And if I kind of went like this and I divide it into thirds, this is right about where 2/3 would be. So it's going to be more than half. It's going to be between 1/2 and 1. 4/7, where is it going to fall? Let's take a look. So if I just split this up into 7ths, that's going to be a whole lot more complicated. So I'm kind of thinking here, I'd have like boom, 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 boom. So about there, so I do 1, 2, 3. So right about here is where I'm thinking 4/7 would go. But I have to be honest, even if I were to put this in a tape diagram, if this were a test or a quiz, I don't know that I would trust myself on that number line. These are kind of similar. They're both more than 1/2 and less than 1, and they're both closer to that half. So if I were doing this on a test, to be quite honest, I would go ahead and I would get common denominators for these. So I'd have something to compare them on. Or, and we really haven't done this, so I don't want to confuse anyone, so if this is going to confuse you, stick your fingers in your ear for like 5 seconds. I can see that I have related numerators, so I could actually turn this into 4/6, and then I would see which one's larger and which one's smaller. Okay, hopefully everyone's taking their fingers out of their ears now. So we're going to go with the way that I think is the smartest way to go, where you're going to have the most reliable answer, and that is to get common denominators. So again, how do we do that? We're going to take the fraction and multiply it by the other fraction's denominator. So I'm going to start with 2/3. And you know what? I'm going to do it over here. And that way we can work on this one over here. Hold on, let me go take care of the puppy. Okay, so I'm going to take this 2/3. And again, the rule is if we want to get common denominators, is that we take the fraction and we multiply it by the other fraction's denominator. And in this case, the other fraction's denominator is 7, right here. So I'm going to do that on the bottom and the top. 2 times 7 is 14, and 3 times 7 is 21. So another way of looking at this is to say that 2/3 is equivalent to 14/21. So these are equivalent. So now, let's work with 4/7. So we have 4/7. And I want to convert that. Sorry, I want to decompose that is a better way of saying it. And I want to do that by multiplying it by the other fraction's denominator, which is 3. So I'm going to multiply it by 3/3 because 3/3 is just 1. 4 times 3 is 12, and 7 times 3 is 21. So now they both are 21sts. Here I have 14 of them, and here I have 12 of them. So having 14 of the same size pieces, having 14 of them is going to be more than having 12, which means that this is larger, which means this is larger, which means the alligator is going to eat 2/3. So 2/3 is larger than 4/7. Okay, so let's take a look at the next problem. So for problem D, you can see that we have here 10 halves or seconds, so 10 halves, and we have 9/4, and we have to figure out which one's going to be bigger and which one's going to be smaller. So for this one, as I'm looking at it, I'm noticing that these are both fractions greater than 1. That's because my numerator is larger than my denominator. So here I'm going to go ahead and rewrite them up. Let me switch pen colors. So I have 10 halves and I have 9/4. So for these, what I want to do is I actually want to convert each of these into a mixed number. So let me start with 10 halves. So if I have 10 halves, what I know for this one, since my denominator is 2, I know that 2 halves is equal to 1. So what I want to do is I want to pull out groups of 2 halves. So I'm going to pull out 2 halves here. I'm going to pull out another 2, so that makes 4 halves. I'm going to pull out another 2, which makes 6 halves. I'm going to pull out another 2, which is 8 halves. And I'm going to pull out another 2, which is 10 halves. 2, 4, 6, 8, 10. So I pulled out 2 halves 5 times. Each one of these is worth 1. It has a value of 1. 2 halves equals 1. So what I could say is that all of these together is actually 5. 1, 2, 3, 4, 5 ones is 5. So 2 halves 5 times is equal to 5. So now let's go ahead and let's work with 9/4. So I'm going to write down 9/4. And then for this one, what I know is that 4/4 is equal to 1. And I chose the fourths because that's in my denominator. So let's see how many groups of 4/4 we can pull out of this. So I have 4/4 once. I have 4/4 twice, so that's 8/4. So I can't pull another 4/4 out because then I'll be up to 12. 4, 8, 12. That's not going to work. So since I already have 8 here, I just need one more to make 9. 4 plus 4 is 8 plus 1 is 9, so that's 9/4. So now I'm going to take these, and remember this is equal to 1 and this is equal to 1, so that's 2 and a fourth, because I keep my fraction. So what I now know is that 9/4 is equal to 2 and a fourth. Now that we've done this, it becomes very clear. If I compare 5 and 2 and a fourth, it becomes really clear which one is larger. 5 wholes is definitely going to be larger than 2 and a little bit. You want to have 5 donuts or 2 donuts and like a quarter donut? You want to have 5 donuts. It's a whole lot more. And what's equivalent to 5 is 10 halves. So now I know that 10 halves is larger, so the alligator's going to eat the bigger number. Okay, we're doing great. So I am going to give you the second part of our secret message or secret words. So the first part you already know from earlier. So the second part is slice. Slice. All right, S-L-I-C-E. All right, so let's do E. And that does not mean that you can go away. You have to still watch the rest of this. Who knows? There might be a third piece to our message. All right. So E. So we have 1/3 and 1/5. So this is going to be one of our quick ones again. We like these. These are the super duper easy ones that are really, they're nicer to work with. And that's because we have something in common. And I'm going to rewrite it. We have 1/3 and we have 1/5. So my numerators are the same. They're both 1. And when my numerators are the same, so here I have 1 slice and 1 slice, well, now I can take a look at my denominators and say, who gets the bigger pieces? Now remember, it's weird because the denominator is telling you how many pieces make up one whole. And remember, the fewer slices, 3 slices is fewer than 5, means that each slice is bigger. If you split a cake among 3 people, you get a bigger slice than if you split it among 5 people. So 1/3 is definitely going to be larger. All right, so let's go to the next one. So here we have 7/3 and 8/4. So my numerators are different and my denominators are different. So when my numerators and my denominators are different, I have a couple of choices. Oh wait, hang on. We have fractions greater than 1. So let me rewrite this just so it's more clear. So we have 7/3 and we have 8/4. So we have another one just like we had in D where we have fractions greater than 1, so we want to convert them into mixed numbers. Remember that. If your fractions are greater than 1, how do you know that? Numerator is bigger than your denominator. You want to convert them. So let's take the 7/3 to start with. So I'm going to write up here 7/3. And I'm going to go ahead, and what I know for this one is that I know that 3/3 is equal to 1. So 3/3 is equal to 1. So I want to pull out groups of 3/3. So I pulled out 3/3. I pulled out another 3/3, so that's 6/3, 3, 6. I only want to go to 7. If I pull out another 3/3, I'm going to be at 9. So I don't want that. So I have 3, 6, and 1/3. 3/3 plus 3/3 plus 1/3 is 7/3. So remember that each group of 3/3 is equivalent to 1. So this is 1 and this is 1. So I have 2. But don't forget your third. So you have 2 and a third. So now we want to compare that to 8/4. So I'm going to write 8/4. And for this one, what I know is that 4/4 is equal to 1 whole. Again, I'm looking at my denominator. And what I want to do is I want to see how many groups of 4/4 I can pull out. Over here I pulled out 2 groups of 3/3. Let's see how many groups of 4/4 we can pull out. So I have one group, 1 4/4. And now I'm going to do another 4/4, and that's 4 and 8. So I found all of my groups of 4/4 here. And I had 2 of them. So this is equal to 1 and this is equal to 1. So which one's larger? Is 2 larger or is 2 and a third larger? Well, they both have 2, but this one has an extra third. Think about it in cookies. 2 cookies or 2 and a third cookies. 2 and a third cookies is a little bit bigger. So I can go ahead and write that 7/3 is larger than 8/4, and I can go ahead and I can write that here as well. All right, so let's take a look at G. So for G, we are comparing, and let me go ahead and rewrite this for us. We are comparing 3/5 and 4/5. So that's a nice easy one because they have something in common. They have denominators in common. The denominators are the same, which means that all my pieces, all my slices are the same. So I just have to see who got more of those pieces. 4 is definitely more than 3 pieces. It's more slices, right? So 4/5 is going to be more than 3/5. That was nice and easy. So 3/5 is less than 4/5. And let's take a look at our last one. So the last one is H. And it says 4/5 and 5/6. So we have to figure out which one of those is greater. So let me first go ahead and rewrite those. So we have 4/5, and we have, you know what, let me do one green and we'll do one red just to really keep them apart. 5/6. So their numerators are different, their denominators are different, so I need to decompose both of those by multiplying the fraction by the other fraction's denominator. So let's start with 4/5. So I'm going to go ahead and write 4/5 is equal to 4/5 times the other fraction's denominator. Just for fun, I'm going to go ahead and write that in red. So the other fraction's denominator is 6. So I'm going to multiply by 6/6. 4 times 6 is 24, and 5 times 6 is 30. So now let's go ahead and let's work with the other fraction. So the other fraction is 5/6. And I want to decompose 5/6 by multiplying it times the other fraction's denominator. The other fraction is 4/5, so 5 is the other fraction's denominator. So now 5 times 5 is 25, and 6 times 5 is 30. So now I can actually compare these much more easily. So I can see here I have 24/30, and here I have 25/30. And 25/30 is definitely more than 24. So I'm going to go ahead and circle that one. So 25/30 is more, which means that 5/6 is more, which means that the alligator is going to eat 5/6. So 4/5 is less than 5/6. And there you have it, my friends. So we added a bunch of different fractions. So we have that here. So we added all these different fractions. We did where the denominators were the same, we did where they were related, and we did where they were completely different. And then we practiced comparing fractions and writing whether they were greater than, less than, or equal to. So make sure you go over this carefully. And if you want some bonus, so we already did the secret code. So here's your bonus with pineapple. All right. So I'm going to go ahead and say good night or good morning to you, depending on when you are watching this. we will have our Google Meet and we will go over this, and then in the afternoon I'm going to post the quiz for you guys. So I hope everyone does really well. You're going to do the actual quiz. I will be available again at our Google Meet to answer any questions that you have before you take the quiz, so don't jump into it, because once I see answers up, I am going to start grading them. But I know you guys are all going to do really, really well. We've been practicing since we had the long weekend. We took a couple extra days to practice. So I will see you all in our Google Classroom. Have a great day. I'm really proud of all your hard work. You guys are amazing. All right, bye.